Well, hello, AB Calculus students. Looks like we're ready to go over how to score the 2018 free response, specifically on this we have questions 4 through 6. So let's go ahead. This is question 4 that we see here before us. So let's take a look. We have our values of h, which are the height of a tree, which is given to us in a table form along with the years that are in the variable t for time. And so we expect to do different things here with this. So let's go ahead, let's take a look at what a lot of the things that we do with this are going to be very familiar. Part A, we're going to be calculating average rate of change. We should know that. We are making a distinction. And then part B, we're using our mean value theorem in part B. Part C, we've got trapezoidal sums, which almost always we're doing some sort of approximation method when we have these tables in those type of situations. So some very typical things that we're going to be looking at here. So let's go ahead and let's take a look at what you need to have for an answer. So first, for this part A, it's worth 2 points. So notice the first thing we see is we must see our difference quotient here. We must see a quotient of difference over difference. So we need to see that expressed in that difference quotient. Unfortunately, I believe that even if you just jump to this, without something here saying that you have a difference between x2 and x1 or t2 and t1, you're not going to get that difference quotient. We need to see a difference quotient. And it does reduce down to 5 over 2. But you could easily list it as 11 minus 6 over 7 minus 5, something where it's a difference quotient. And then your interpretation gets you a point, which it's important that you specify, and you have to write this out in English, that this is the rate at which the height of the tree is changing, and you must include units in meters per year, and you must include that it is at the time at 6 years. So all that has to be there to get your 2 points. For part B, we're checking on our MVT. Notice we need a difference quotient again. So 1 point for our difference quotient. It's a different one than the previous one. And our difference quotient is equal to 2. So then our conclusion, first off, to get our conclusion point, this is the hard point. We must reference that it is differentiable and continuous. That's a requirement for the mean value theorem. On a closed interval, we can either specify this closed interval or we can say on a closed interval. Then we have to reference the mean value theorem and state what the conclusion is, that there does exist a value c in between 3 to 5 such that the derivative at that value of c is equal to 2. So all of that has to be present to get those 2 points. Well, yes, this point's pretty easy for the difference quotient. This point's pretty difficult to get. A lot of things have to be there for that second point. Okay, for C. So for C, it's very interesting. Now we're calculating average height, not average rate of change. So since we're talking about the average value, we know it is the integral divided by the interval, or in essence 1 over the interval times the integral. But the key here is the integral is accomplished by a trapezoidal sum. So you get 1 point for what is inside the parentheses here. You must see a sum. There must be the sum, and these have to be distinguishable. So they list it this way. These have to be distinguishable as areas of individual trapezoids. But you could easily write it as 1 times 1/2 times the 1.5 plus 2. And then over here, 1/2 times 2 times 2 plus 6. And they have to be written out as a sum in that manner there. I think that you're okay if you go ahead and you add those up and you just write 3.58. But you must have the 1/2 times the 1 times the 3.5 and the 1/2 times the 2 times the 8. It must be distinguishable as trapezoids that you're finding the area of each one and you're adding them up. And then your approximation point, you have to know to multiply by 1/8. and you have to do it correctly. By the way, this right here gets you both points. If you have this here, that gets you both points. Okay, then for part D is worth 3 points. So the first thing, there are 2 points for doing a correct implicit derivative here. You must derive with respect to t, this g of x function, which leads to us getting this value right here. Now you can leave the dx dt as a factor of each one of these if you want to, that's fine. So in other words, you could have, when you write it out, you could have 100 times 1 plus x dx dt minus 1 times 100x dx dt. That would be fine. List those dx dt's there. If you factor it down or simplify down, it still has to be correct. And then you get 1 point if you correctly substitute in and get your answer of 3/4. Or you can leave it unsimplified so long as it does reduce to 3/4. If you don't have your dx dt as a factor of each one of these terms, 1 is the biggest number of points you can get. So we must see that dx dt as a factor of each one. In other words, that part that's the implicit derivative. Okay, score that out of 9. And then let's move on to question 5. So question 5, we have the average rate of change again. So we need to see this difference quotient. So this one would either be this would work, or they would let you do the pi minus 0 and just put pi there. So either one of these things here, I should say, sorry, this is okay if it's followed up by this, but you need to have this. You actually have to evaluate those. You can't leave them just in that form there to get your value. So you got to get that. All right, part B. So for part B, you get 1 point for correctly getting the first derivative. That's listed right here. It's okay if you factor the e to the x out, but you don't need to. And you get a second point if you correctly evaluate and get the e to the 3 pi over 2. So you must have that evaluated correctly to get that slope of e to the 3 pi over 2. Then for part C, so for part C, we see this is an example where we're using the candidates test again to find an absolute minimum. So you get 1 point if you know you have to look for critical points. That's where the first derivative equals 0. So if we see somewhere where you're looking for that first derivative equals 0, then you get 1 point. That should lead you to identifying the 2 candidates of pi over 4 and 5 pi over 4. If you identify both those candidates, you get a second point. Now, to get your final point, you must recognize you have to check endpoints, because your candidates are the critical points, which you identified there, and the endpoints. And you must check the value at each one of those. And then you simply look for the minimum. And there's only one here that is clearly, even though these don't know exactly where these fall, the key thing is we're looking for minimum. This is the only one that's negative. This has to be the minimum. So we can say that this is the absolute minimum, and it occurs at 5 pi over 4. All right, then D. So for D, you get 1 point for identifying that G is continuous at pi over 2 and the limit's equal to 0. So that's the first thing to do is it's continuous at pi over 2, and when we go ahead and substitute pi over 2, we get that it is 0. So that we can get just by directly substituting in. Then for number 1, we must apply L'Hopital's rule. So we must say by L'Hopital's rule something where it says using L'Hopital's rule in some way, shape, or form. So in other words, we know that when x goes to pi over 2, we know this is of the form 0 over 0. So we take the derivative of each of these. We see that in action there. And then we get our answer correctly here. So just saying using L'Hopital's rule is not enough. You actually must demonstrate that you take the derivative of the top and the derivative of the bottom. And notice here, If you don't use limit notation at all, the maximum you can get is 1 out of 3. Okay, score that out of 9, and let's go on to number 6. So number 6, we have our slope field here. This is our essential differential equation problem. So for part A, you get 1 if you have your solution curve through the point 0, 2. So this solution curve right here. And the key thing here is it's got to go through this point 0, 2. It must start from above the x-axis. It must come down, go through the point 0, 2, and then go back up above the y-axis, above the x-axis. And then you need your solution curve through the point, this is the solution curve through the point through 0, 2. That straight line through there. And then this is the curve through the point 1, 0. So it must come down, must cross the y-axis at a negative value, and then go up through this point here and continue like that. So it's got to have this general shape to it. All right. So for part B, first we get 1 point for our correct tangent line equation, which is found right here. It's okay if you call it y minus 0 is equal to 4/3 times x minus 1, or if you distributed the 4/3 through and called it y equals 4/3 x minus 4/3, that works too. And then if you correctly plug in to approximate and get negative 0.4, you get your second point. For part C, we have our solution to our separable differential equation. So you should be getting pretty good at grading these by now. So you get 1 point if you separate your variables. So we see the separation of variables right here. The dy over y minus 2 squared and the 1/3 x dx. That gets us 1 point. If we take correct antiderivatives, so we get this negative 1 over y minus 2 and this 1/6 x squared. That gets us 2 points, 1 point for each antiderivative. And then our plus c here gets us another point. And if it gets us another point, not just putting plus c gets us the point, we actually have to substitute in correct values here for y and for x, and then go ahead and solve for c. So we don't necessarily, and then after we get the correct c of 1/3, we must then express it in terms of y. That gets us our 5th point. Notice, as usual, no separation, no points at all. If you don't find the correct plus c, 3 out of 5 is the most you can get. All right, score that out of 9 and the whole thing out of 27. Go ahead, take a picture and send that on in. Hope things are going well, and we'll look forward to having another video for you tomorrow.